Okay, so today we're learning about spheres. Okay, a sphere is the locus of points in space that are a given distance from a given point. So in all directions from the center point, the same distance away, that would create a sphere. The center of a sphere is the point where the distances are measured from. So in this case, this is the center. Then the radius of the sphere is the segment from the center to the edge of the sphere. So this is the radius. A chord of a sphere is a segment whose endpoints are on the sphere. So this is a chord. The diameter is the longest chord that passes through the center of the sphere. You don't have a diameter pictured, but it's the same as the diameter of a circle. Goes through the center, okay, and hits the two edges. The great circle is the plane that passes through the center of a sphere, forms the great circle. The circumference of a great circle is the circumference of the circle. So this right here is the great circle. It cuts, if I were to cut the sphere right there, it'd cut into two equal parts, which comes to the hemisphere. Okay, we have to think about the globe. The globe has the northern hemisphere and the southern hemisphere. A plane passing through the center and divides the sphere into two congruent regions called hemispheres. There you go. And again, if I cut a baseball in half and I showed you the bottom of it, it would have that great circle. You would see that flat surface would be the circular, and it would be called the great circle. Okay, the surface area of a sphere formula is surface area equals 4 pi r squared. Okay, so remember, surface area is just if I took a baseball and I wanted to paint all the outside. It doesn't fill it up, it just is on the outside, what that area is. So I'm going to find the surface area of the sphere. So surface area equals 4 pi r squared. Again, highlight that or underline it. You want to memorize that formula. Just like we've memorized all the volume formulas, we need to memorize the surface area formula of a sphere. So here we gave you that the radius is 4, so we're just going to plug it in. Surface area equals 4 pi times 4 squared. We're going to do the math. 4 squared is 16 times 4 pi. I'm going to do 4 times 16 now. Get my surface area to be 64 pi. And then I'm going to plug into my calculator. So I have my surface area equals 201.06. Does the 6 make the 0 move up? Yes. So my surface area is 201.1 and then feet squared. Area is squared, volume is cubed. Any questions over that? The next one, we're going to work backwards. They gave you the surface area, and we want to find the radius. So again, we're still use our formula, surface area equals 4 pi r squared. This is my surface area, so I'm gonna plug it in for surface area. So 804.2 equals 4 pi r squared. What should I do first? Divide by 4 pi. So I'm going to plug that in my calculator. Okay, you should have gotten 63.99. I'm guessing a lot of you did not get that. Okay, so when you plug this in, if you're going to divide by 4 pi, you need to put the 4 pi in parentheses. Okay, if you don't do that, then you're going to get like 600 and something, right? So once you do that, then you should get 63.996, and that still equals now r squared. If you don't put it in parentheses, you're going to get it wrong. So if you don't want to put it in parentheses, you're going to do 804.2 divided by 4, and then whatever that answer is, you're going to divide it by pi. Otherwise, you have to put them in parentheses. Any questions over that? Yes. 804.2 divided by, use a parenthesis, 4 pi. It equals. Yes. Okay. So then you're going to enter it in the calculator, do 804.2 divided by 4 equals, and now divided by, just hit divided by, and then pi. It equals. Okay. Okay, then you need to square root both sides. When I square root this, I'm going to put the square root and then put answer. That's how you plug it into your calculator. Okay, and then the radius equals 7.999. Okay, the 9 makes the 9 move up, which makes the 9 move up, which makes the 7 move up. So the radius is 8, and this is centimeters. Any questions over that? We're all good? Okay, now we get to watch another YouTube video. Super exciting. We want to find the volume of a sphere, and we want to understand why our volume of a sphere is the weird formula that you're going to see. We don't. I just shows you how to round it. Just showing you how to round it. You just need 9, 9, right? And that'll make the 9 go to a, or the 7 go to an 8.
R cubed gives you the volume of the sphere. But where does the formula come from? First, we'll draw a perfect sphere and fill in its volume. next, we will divide the sphere into equal-sized pyramids with square bases. So let's take a look at one pyramid, and remember that its volume is equal to 1 over 3 times the base times.
Okay, so we just took our wonderful sphere. We wanted to make it into congruent pieces that we knew volume of, okay, in order to derive the formula for the volume of a sphere. So we cut it into these little squares that ended up being pyramids when you put it all the way to the center. Does that make sense? Everyone's with me, okay? And again, the formula for the area of a pyramid is 1/3 the area of the base times the height.
Right. Now let's quickly show that the height of all the pyramids that make up the sphere is actually equal to the radius.
Okay, so the height of our spheres.
So our equation becomes 1 over 3 area base times radius. And we will simplify this equation by replacing radius with r and area base with b. We will be numbering the bases, so we start with base 1, and our equation is base 1 r. So in order to find here, we simply have to calculate the volume of the pyramids and add them together, giving us a simple formula. So lining up, and we have volume equal to base 1 r over 3 plus base 3 r over 3 to process up until the last pyramid. Now we don't know how many pyramids.
Okay, so basically we've taken all of the pyramids that were in our sphere and we lined them all up. In order to find the volume of the sphere, we would have to add up all of the volumes of those pyramids, right? But do we know how many pyramids I have in there? No, I don't know how many. I could have 5, I could have 3,000. I don't know, okay? So that's what they're explaining that you're gonna do. What they wanna find is what the area of those bases are if I added them all together. Okay, I need to find all those volumes and add them all up.
So we just let base n r over 3 simply represent the last pyramid. So having added up the pyramids together, we have this complete simple formula to work with.
Super simple.
So next, we will use algebra and begin by factoring out a 1 over 3. And we will also factor out the radius, giving us r over 3 times the sum of all bases. So now let's concentrate on the sum of all bases. And remember, these are the bases of the pyramids that make up the sphere. And as you can see, the bases actually form the surface area of the sphere. So the sum of all bases is equal to the surface area, which is equal to 4 pi r squared. Now, a quick explanation for why the surface area is 4 pi r squared is first we'll look at our sphere and take its largest possible circumference. With that circumference, we'll make a circle. And now the amazing fact is the surface area of the sphere is equal to exactly 4 times the area of the circle. The area of each circle is pi r squared. Combine them together and we get 4 pi r squared. So now let's go back to our simple formula and replace the sum of all bases with 4 pi r squared. Now we combine the r's together to get r cubed.
Okay, so did you guys get that the adding up all those bases of your pyramids was just the surface area of your sphere? And we have our surface area formula, which is 4 pi r. So now we're just going to take the area of the volume of a pyramid, which was 1/3 the area of the base times the height. And remember, the height was the same as the radius in this. So now we have all of those pyramids added together to be 4 pi r squared. They multiplied the r squared times the r and got r cubed.
Cubed. Now we simply rearrange the equation to get 4/3 pi r cubed.
Okay.
So 4/3 pi r cubed gives you the volume of any sized sphere that exists.
We learned how to derive the formula for volume of a sphere. Okay. So what we just did was we broke our sphere into all those little pyramids.
Let's suppose that you're writing
Oopsie.
a really important email to a colleague.
Oh, this is going to show. No, stop playing. Okay. Okay, so we had all of these little pyramids that we added all up to get the formula for the volume of a sphere, and then you just need to memorize this. Volume equals 4/3 pi r cubed. Highlight it, memorize. Any questions over that? Okay, so now let's use it. On the back, you want to find the volume of the sphere. Okay, so to find the volume of that sphere, we are given the radius, r equals 4. We're just going to plug it in. So volume equals 4/3 pi times 4 cubed. Now let's review how to plug this into your calculator. So 4 cubed in your calculator, you want to find this button. And plug that in. Okay, you should get 64. Was anyone not able to get 64 on their calculator? Please make sure you know how to use your calculator so that on a test you're not getting something wrong simply because you don't know how to use it. We're all good? Okay, then I'm just going to multiply the 4 times the 64. And that should give me 216. Wait, is that right? Let me try that. 256, sorry. 256. And then you're still over 3, and you have pi on the top. Any questions over that? Now, plug this into your calculator. 256 pi divided by 3. And you should get the volume equals 268.08. Does the 8 make the 0 move up? Yes. So your volume is 268.1 and then feet cubed because it's a volume. Any questions over that? We're all good? Okay, do the next one. We should have got our volume to equal 1,436.75. Does the 5 make the 7 move up? So your volume is 1,436.8 and then centimeters cubed. Any questions over that? Okay. Now we're gonna work backwards. Okay, this time they gave you the volume and they want you to find the radius. So you're still gonna be using your volume formula, which is 4/3 pi r cubed. This is your volume. So you're gonna plug it in for volume. 904.8 equals 4/3 pi r cubed. Any ideas on what I should do first? Yeah?
You divide 4/3 such that
Okay. What's the same as dividing by 4/3? Multiplying. Let's multiply by the reciprocal. I want to get rid of the 4/3, so I'm going to multiply by 3 and divide by 4. Multiply by 3 and divide by 4. So this is like it's over 1. I'm just going to multiply straight across. So 3 times 904. Remember, I'm going to show you all kinds of steps in this. So you know, remember what happened. So 3 times 904.8. That gives me 2714.4, then still divided by 4. These will cancel out, and I just get left with pi r cubed. I'm now going to divide it by 4. And I get 678.6 equals pi r cubed. Any questions so far? Did I lose anyone? No? Okay, any ideas of what I should do next? Good, now I should divide by pi. I want to get rid of the pi, so I'm going to divide by pi. And I get 216.0. 0. Does the 0 make the 0 do anything? No. And that still equals just r cubed. Okay, does anyone remember how to get rid of something that's cubed? You gotta remember way back to first semester. What is it? Say it, Alex. It's okay if it's wrong. Yeah? Yeah? Cube roots, right? To undo a square, I square root. To undo a cube, I cubed root. So let's review how to do this in our calculator. Okay, so when I do this, I take a square root and I put the little 3 there, remember? I take the square root and I put the little 3 there. So on your calculators, you're looking for the button that looks like this. It'll have a box here or an X there. It's usually right above that arrow one. You have to hit the shift button or the second button. Anyone not find that? Right here. So it's right above that one. Okay, yes, you have it. Let's see. Right here, X and Y. So you're gonna hit 3, then that, and then 216. Oh, that wasn't right. Let's try it again. We'll figure this out. There you go. Okay, hold on. Okay, so can everyone get this? So you're gonna hit the 3. Most of us are gonna do this. 3, then that button, then 216, and we should get your radius to be what? 6. No. So 6 meters. So what you need to do is you're going to put the number that's inside first. You're going to work backwards. So you're going to do this way. 216, the button, then 3. Okay, anyone not able to get this on their calculator? Shh. Everyone was able to get 6 on their calculator. Okay. Next one. Okay, we're going to do the same thing. They gave you the volume. I want you guys all to find the radius. Then once you find the radius, then you can find the circumference. Okay, so everyone tries this one in their pairs again. Most of us came up with the radius. Okay, but let's just go over it one more time. It should have been 113.1 equals 4/3 pi r cubed. I'm going to multiply by the reciprocal. That's going to give me 339.3/4 equals, these will cancel out, just pi r cubed now. I'm going to divide it by 4. And that gives me 84.825 equals pi r cubed. Then I divide both sides by pi. And that gives me 27.00. The cubed root, and you get your radius to be 3. Okay, so most of us struggle with the circumference. Circumference equals 2 pi r. So my circumference is 2 pi 3. Multiply 2 times 3 and get 6 pi. And then I plug that in my calculator. That gives me 18.84. Does the 4 make the 8 move up? No. So my circumference is 18.8, and then this is just inches. Yes.
What if we multiply 2 times pi and then times 3?
Will be the same answer, right?
No, I got 18.9.
It rounds for you.
Yeah.
Yeah. Okay, so it's gonna be slightly off on the rounding. So I would just multiply by the pi at the end. Any other questions? We're good? Okay, next problem. Find the volume. Okay, so we have 2 figures here. I'm going to find the volume of the cylinder first. Okay, does anyone remember the formula for volume of a cylinder? That's the area of a circle, is pi r squared. What? Area of the base times the height. Very good. A cylinder is the area of the base times the height. A cone would have that 1/3 in front of it. So I don't need the 1/3 because this is a cylinder. You need to know these things, guys. Okay, so the area of the base of the cylinder is a circle, which is pi r squared, the area. So the area of the base is pi times 5 squared. So the area of the base is 25 pi. I'm going to leave pi right there. I'm not going to round till the end. Okay. So then my volume is going to be the area of the base, which is 25 pi times the height of 7. So I'm going to multiply 25 times 7. 175. Thank you. 175 pi. And now I can multiply that out. So my volume equals 549.77. Does the 7 make the 7 move up? What is it, class? Does it move up or stay the same? Moves up, okay. Sorry, you guys are falling asleep on me. It's not nappy nap time. As much as we would love that. Okay, so that's the volume of the cylinder. Now we need to find the volume. What is this shape on top? It's a sphere, but half of a sphere. What's half of a sphere called? Hemisphere. I'm spelling very badly. A hemisphere. Okay, the hemisphere is similar to a sphere. It's only just half of it. So I'm going to take the volume of a sphere and then divide it in half. Okay, because that's all a hemisphere is. So the volume is the volume of a sphere divided by 2. Because I only want half of it. Any questions over that? So my volume is 4/3 pi r squared or cubed. That's the volume of a sphere. My radius I have right here of 5. So I'm going to plug that in. Volume is going to equal 4/3 pi times 5 cubed. Volume equals 4/3 pi times 125. 5 cubed is 125. Then we're going to times that by 4. So 4 times 125 is 500/3 pi. So I'm going to plug that into my calculator. So that gives me 523.59. Not quite there yet, because what do I have to do? Divide it by 2. That's the whole sphere. I want half of a sphere. Okay. So to divide that by 2. So this volume now is going to be 261.79. Yes. We already divided by 3 up here, right? 500 pi divided by 3 gave me this number. Okay, so that volume is 261.8. Now let's just add the two volumes together. So 549.8 plus 261.8 equals. Good job. So my volume equals 811.6 feet cubed. Any questions over that? We're all good? Okay, next one. Okay, we have two shapes here. We have the cone. And then you have the hemisphere again, right? What's different about this? Anyone have an idea of what's different about it? At the very end, what should we do? Here we added the two together. Very good, because the cone is concaved. So I have to take away the volume of that hemisphere. So you're going to do the cone minus the hemisphere. At the end. Does that make sense? Okay. Homework.